Hi, everybody. How are y'all doing? Woo. Okay, cool. So I just want to start. Let me just open this up here for a second. Can you hear me okay, by the way? Okay, cool. So I already got a sweet intro there. Thank you very much. But just really quickly about me, that's an actual photo of me. Those are my real biceps. My real tattoos, 100%. I'm a web application developer. I work at a software consulting agency in TWG, and I see a couple of TWGers here. Hi. I also teach at HackerU, which is a Toronto-based coding bootcamp, as well as at Canada Learning Code, and I'm a mentor and TA with the Bridge School. And I'm going to be tweeting. I already actually messed up my timing on this. I already live tweeted the slides for this talk. So if you want to cheat and get ahead, or later if you want to see the slides, just follow me on Twitter. I posted them there. So I wanted to start by, this talk is called the React Cookbook, and I wanted to start just with a show of hands. How many people here cook without following a recipe? How many people here cook without following a recipe? So I'm very, very impressed because personally I have to say that that is not an ability I have, but I'm sure that y'all, when you go to the grocery store, you don't even bring an ingredient list with you. You squeeze produce and smell it just to know its freshness or pluck its leaves or whatever. And you go home, you cut up all your ingredients, you know what you want to make, you go home and you end up with something that looks like this. And I'm very envious of you. I think that's very, very impressive. I, on the other hand, don't have this ability. I need to follow a recipe. In fact, Halloween's coming up. I was doing a little bit of October cooking. Here's a live look of me doing a bit of cooking. So definitely not a strength that I have personally, and this is the output of what I produced. I think you should give me marks for presentation, personally. It's a bit of a half-moon arrangement there. I typically need to follow a recipe. And I find that when I follow a recipe, I do end up with delicious tasting food. And what I wanted to share with you is that I also find that when I follow code recipes, I end up with delicious tasting React apps. Now you might be like, see what I did there? And you might be thinking a code recipe. Well, what is a code recipe? Well, we actually have a name for this in development. This is what's called a design pattern. A design pattern. And what is a design pattern? The definition of a design pattern, according to, I believe, Wikipedia, is academic source, is a solution to a recurring problem. A design pattern is a solution to a recurring problem. So for example, we have some kind of recurring software problem, we follow a design pattern, and we end up with some kind of delicious, desirable code-based outcome. So what I want you to do is I want you to think about design patterns as the kind of recipes that help us cook delicious React apps. And the goal of this talk, it's called the React Cookbook, the goal of this talk is to add some recipes to your cookbook. So we're going to be adding a few different recipes to your cookbook so that the next time that you work on a React app, or even the current React app that you're working on, you can kind of cook with these recipes and end up with a presentation that looks better than that brie half circle. So we're going to be learning these recipes, and I just want to say that these are not recipes that I created. I didn't invent them. They're recipes that I have kind of gathered and collected from my time building React apps. And specifically, these are recipes that I would attribute to what I call the React top chefs. So here we have Chef Dan Abramov, and we're going to be looking at a few different chefs, and we'll point out the chef as we get to them, and talk about the specific pattern that either they created or they championed, something like that. So for our cookbook today, the recipes that we're going to be learning about, we're going to learn about 3 recipes. We're going to learn about the context API. We're going to learn about a pattern called presentation and container components. And then we're going to learn about renderprops. If any of you attended the Wes Boss workshop, I believe he actually covered some of these as well. So I'm glad we're not on the same day in the same slot. So we're going to start by doing some cooking. And we're going to start with our first recipe. Now, our first recipe that we're going to talk about is the context API. This is a recipe that was championed by, I first heard about it by Kent C. Dodds. It's also been a part of React for a very, very, very long time. However, a new version of it came out quite recently. And when it did, Kent Dodds, who has a newsletter where he talks about just different React patterns, things that he's excited about, libraries that he's working on, he kind of reintroduced the idea of using the context API. So I think this is a statement that you can all kind of agree with. I think when people first encounter React and the idea of passing props inside of a React app, it can be very, very frustrating. Now, if you're passing props, like let's say one level down, here we have an app component that's passing some props to a menu component. That's not that big of a deal. But what happens if you have, for example, a sign-out component, and you want your dashboard to pass a prop into it? Well, if it is rendered by an intermediary component, in this case the sidebar component, we have to pass it through sidebar in order to get it into sign-out. And we have to do this even if the sidebar component doesn't even use that prop at all. So we end up passing this prop down our tree through a component that doesn't even need it. And that's like not the best. But then you can end up in a situation like this, where you have to pass it through a sidebar, through settings, into a reset password component. So we're passing this prop down multiple layers inside of our app. This is problematic because we end up passing this prop through a bunch of intermediary components that don't need it. It's also possible that through this journey, during this time, as it moves between all of these props, sometimes it changes names for some reason. The developer decides it's going to be called something else. And so later, when you come back and you try and find the origin of this prop, you have like 4 or 5 files open as you're trying to track it all the way back up the chain. There's actually a name for this, and again, Kent Dodds was the first person I heard use this before, but he refers to this as prop drilling, or prop threading is another name that I've heard for this. And prop drilling is really, really frustrating, and I think especially when people are new to React, it's something that they experience quite early on in their journey. If you were to ask like someone at your work, I'm having this issue with prop drilling, I keep passing this prop down the chain, and I want to know, is there an easier way to kind of resolve this issue? They might say something to you like, oh, you should use Redux. So then you go, okay, I've heard of Redux. Maybe you've used it before. I'm just going to go check the documentation and see what it says. So you end up looking at like a diagram that looks like that. And you're sort of like, why is this so hard? Like all I wanted to do was just like pass a prop down without having to pass it through the intermediary components. So why do I now have to add the boilerplate? How would I have to manage the overhead of Redux? And the truth is it's hard because like sometimes we want our state to be global, but React, the kind of unidirectional data flow of React, the whole model that data moves from the top down, React doesn't really want us to have or access global state in this way. There's no real way immediately visible to you to access parent state from a deeply nested component. Until now. Actually, it's always been there, but it's become more popular recently. But yes, until now. So this is an introduction to the first recipe we're going to be talking about today. This recipe is called the context API. This definition comes from the React docs, which are great. And it just says a way to pass data through the component tree without having to pass props down manually at every single level. So literally what we just described. This gives us the ability to access a prop from lower down our tree without needing to pass it through the intermediary components. So if we look at this diagram here, this is a situation we had before. We had a profile component that had to pass a prop from sidebar and settings so that it could be accessed by reset password here. Well, with the context API, we'll be able to do this instead. So we'll have our parent component here, profile. It's going to have the data that we want to have accessed by the reset password. So how does the context API actually accomplish this? It accomplishes it using two kind of key components. The first one is called the provider. And you can think of the provider as a kind of global state container. Just picture it kind of like a big object in the sky, essentially. So it's some kind of object that we're going to have access to further down in our chain. And the provider is going to be, it's going to make this information available to us through another component, which is called the consumer. So the consumer has access to the provider. We'll see that anywhere we render the consumer in our component tree, we'll have access to any data that is stored inside of the provider without needing to pass that data down the tree. So setting it up is actually really, really straightforward. And if any of you have experience with Redux, I think you'll appreciate the simplicity of this in comparison. So the first thing that you do is you call a method that's actually just built into React. You call react.createContext. And here we're destructuring two components off of the return value of createContext. We're destructuring a provider component and a consumer component. And then what we're going to do is at the top of our state tree, we're going to wrap our entire app inside of this provider component. Or at least we're going to wrap the part of our app that we want to have access to this information elsewhere. In the provider component, we're going to pass a prop of value. This is a prop that is like predefined. And whatever we pass into value, that's going to be accessible by the consumer. And the consumer is going to be rendered somewhere else in our tree below. So it just needs to be rendered in a component that is a child of the provider. So, for example, let's imagine we have an app component that's storing a little bit of user data in its state. Here we have like a username of Guy Fieri, excellent cook. And what we're going to do is we're going to take this user data. You can imagine this came from an API or something like that. We're not going to worry about that part of it. It's not relevant for this. But we're going to take that data and we're going to pass it into the provider component through this value prop here. So you can see that we're passing the entire state tree here. We're passing this.state into the provider. And within the provider, you can see that we render a dashboard component. Now, the dashboard component doesn't receive any props. We're not passing this.state.user into it or anything like that. And then as we move further down our tree, we can see that our dashboard, maybe the dashboard renders the sidebar. And the sidebar doesn't take any props in it at all. And then in the sidebar component, when we render it, you see that here we're actually also rendering our consumer component. And inside of our consumer component, you see that we have this function here, which receives a parameter of value. And if we actually grab value.user.name, we'll be able to print out Guy Fieri. So we'll be able to access this state value from the top of our tree without needing to pass it down through intermediary components as props. So just to visualize what this looks like, we have our app component that has a provider inside of it. And then further down our tree, we have this consumer component, which is accessing data from the provider without it needing to move in between dashbar and sideboard. You can also have consumers at multiple levels of your component tree. So if that information needs to be accessed in multiple different areas of your app, which oftentimes with user data, for example, it does. Maybe you need to know in a sign in, sign out whether the user is currently logged in, whereas like somewhere else you need to know some other piece of information about their user authentication. You can just render additional consumers there, and each one of them will have access to that value from the app component. So if you were to visualize that, it would look a little bit like this. We have two different consumers, and both of them are accessing this data from the provider at different branches of your state tree. And you can even get like more complex than this if you want to. So you can end up with something like this, where you have kind of branching components in your app, each one of them that's rendering a consumer that's subscribing to this provider up here. So the huge benefits of this pattern over like passing the props down or anything else is essentially we're eliminating this issue of prop drilling, of needing to pass this prop down multiple levels inside of our app. And we're also eliminating the need for Redux at this juncture in our application. This is, I want to just a caveat with this like pattern. This is not that you don't need Redux, you can just use context API. That's not what I'm saying. What I'm saying is a lot of the common use cases that people initially use Redux for, which is to avoid this sort of prop drilling, you can just start by using the context API. So it gives you the benefit of deferring that decision to a later date down the road of your web application's like life. And you'll see that that's also very important like as we go on, being able to defer decisions until later. So when do you use it? When do you use the context API? Well, you use it when you find yourself passing props like all the way down your tree so they can be accessed lower down. If you find that you do have some global state that you need to know about everywhere in your app, and you will find that when you build your web application, there are certain things that you need in all kinds of different places in your app, like user settings, for example. And if somebody tells you that you need Redux, just like stop, think for a minute, and ask yourself if what you're trying to do can be accomplished by the context API. And if it can, I would suggest starting there before trying to learn the overhead and boilerplate associated with Redux. So what can you cook with it, with this recipe? You can cook a bunch of stuff. Some examples would be like a shopping cart system. So if you do some kind of global shopping cart management in your app, Context API is really good for keeping track of like whether or not the cart is open or closed or what's in its inventory. If you're doing internationalization, so you're managing translations across your app and you need to know like what language is currently active and where you want to store your translation strings, you can use it for that. It's really helpful for modals, again, because like in different parts of your application, you need to know like how to be able to open a modal from anywhere or close it. And then it's also really good for building like a general theme provider. So if you want to have like specific styling that you want to manage in like many different levels inside of your application, it's quite useful for that as well. Okay, so that's the first recipe that we covered, the context API. I now want to introduce you to the second one. And the second one is presentation or container components. This is comes from an article that I read in like, I think it was like 2015, so it's like quite old, but I actually maintain that this is probably one of the most important patterns in React, one of the most important recipes in React, and I actually think it's one of the most important ideas in web application architecture, period. So I really, really recommend that like you not only think about this in the context of React, but also just in terms of building web apps. So I want you to imagine for a second that you were asked to build this weather widget component. So we can see that this weather widget, it surfaces some kind of information about the weather, and then it also has this kind of visual component to it. So we're rendering some kind of content onto the screen. So if we're going to build this, we need to kind of think about two different things. We're going to need to request some weather data from our API that keeps information about our weather, and then we're going to display that data on the page. So you're like, okay, cool, I know how to do this. It's like pretty straightforward. I'm going to build this component. It's going to be called weather widget. And when the component mounts, I'm going to request the weather through getWeather. And then in the render method, I'm going to just display that content. I'm going to display the information about the weather onto the screen. This is fine. You're like super stoked about your component here. It's like really small, very portable, etc. But then what happens is over time, you actually need to do more stuff here. They want you to add like a 12-day forecast to it, be able to show like Fahrenheit and Celsius, all kinds of other things about the weather. I don't really understand how the weather works, but they want you to do all this other stuff. And so you start to expand your component, and it ends up looking a little bit like that. And that is bonkers. This is so big that I had to like zoom out and take 2 screenshots in order to get it to fit on the screen. And this component is suffering from what I would describe as like, this is a bloated component. This is a component that is too big. And why is this problematic? This is problematic for kind of 3 main reasons. It's really difficult to reason about. When I say reason about, I mean it's really hard to look at it and understand like WTF is going on. Do you know what I'm saying? Like it's really hard to know what it's doing because there's so much code there. It's really hard to modify and reuse. So like you try and change it and it like breaks or you just can't really use it in multiple places because it's so specific to the one area where it's being used. And it's also super unfriendly to other developers. Like it feels like you can't no one can touch that component because if anybody touches that component, it's just going to explode into a million pieces. So how do we avoid this? How do we avoid this pattern of like these bloated components that are like untouchable and really scary? So this is the pattern. So it was proposed by Dan Abramov in this 2015 article, Presentational and Container Components. And the key idea of this article is an idea that's not exclusive to React, but he's introducing the notion of separation of concerns. Separation of concerns is an incredibly powerful concept when it comes to web application architecture and just programming in general. What do we mean by a concern? A concern is literally just something your code is responsible for, something your code cares about. And if we think about our weather widget component, it kind of cares about 2 things. It cares about fetching data, and it also cares about displaying data. So these are our 2 concerns. And the idea of fetching data, this is a logic-based concern. It has to do with like managing state, going and requesting data from the API. And then displaying that data on the screen, that's a UI concern. It has to do with like a visual representation of something. So what Dan Abramov proposes in this recipe is he proposes that we take these 2 kind of disparate but connected things and we actually separate them into 2 different components. First, we have our container component. And our container component is going to be responsible for managing the logic of our weather widget. And then we have our presentation component. Our presentation component is going to be responsible for the user interface. It's going to be responsible for what the user actually sees. Let's start by talking about the container component. The container component is responsible for what our widget actually does. In our case, aka the logic. So in our case, the widget is responsible for getting data and storing that data in state. And what Dan Abramov proposes is he proposes that we call this component whatever the thing is, container. So we have weather widget container in this case. And if we look at like what this component actually looks like, we have this component did mount here, which requests the data and stores it in state. And that's all the container is going to be responsible for. It's just going to be responsible for requesting the data and storing it in state. But what about the render? Like, what does the actual UI for this look like? Well, that's where we introduce the presentational component. The presentational component is what the thing looks like. And again, Dan Abramov recommends if the container is called like weather widget container, we just lop the word container off here and we call the presentational component weather widget. So now we have these two components, this weather widget container component and this weather widget component. And what will happen is that the container will actually render this weather widget component. It will render it, and it will pass in any data that the weather widget needs to know about. In our case, it's going to pass in the state data that's keeping track of information about the weather. And then the weather widget component, our presentational component, it looks like this. So what it's doing is all it's responsible for, all it's concerned with, is receiving some props, which have information about the weather in them, and then rendering those onto the screen. So there's a couple of things you'll notice really quickly right off the bat. The first is that we can use a functional component here. We don't need to use a class-based component. And the reason that we can do that is because there's no state being managed in this component, and there's no lifecycle methods being managed in this component. And what that means is that this is a much, much, much simpler component, and therefore like a much easier to reason about component. The only thing that this component is concerned with is displaying some content onto the screen based on some data that it received. So why is this pattern useful, this container component and presentational component pattern? It's useful because it makes the code a lot more reasonable. Easy to read, I mean, sorry. So if you go back and you think about, that bloated component that we were looking at before, we've taken that content and we've split it into two different components. And that is going to make it a lot easier for us to also hunt down bugs. Basically, what we can do is if we see that there's some kind of if there's some kind of issue with the data that's coming back from the API, or something's not being set in state properly, something that is kind of a logic-based issue, we know that we need to debug this inside of the container. Similarly, if we look at the thing on the screen, and as we look at it, it looks, as the kids say, jacked, it looks messed up, then we know that that's a presentational issue, that's a visual issue, and we can debug that inside the presentational component. So we're able to really isolate our potential technical issues with our components and debug them in a way that is like, we'll just be able to debug faster and we'll have more confidence in our approach. Technically, this pattern also makes the presentational component, the weather widget, reusable in other places if we wanted it to. I'm a little bit skeptical about this. This is something that Dan Abramov says. I'm a bit skeptical about it because it requires that presentational component to receive the identical props as it would from the current container. But theoretically, if you had another container elsewhere and passed data into this component, you could theoretically use that presentational weather widget elsewhere. And then the other thing that's really good about this pattern is that it's much more testable. So for your presentational component, if you're familiar with snapshot testing, you could easily write a snapshot test for this and just mock the props that are being passed in. Then you have like total coverage on that component, you're good to go. And then for the container component, that one you could unit test with more of a kind of logic-based approach. So the question is like, when do I use it? When do I know to use this particular recipe, this presentational and container component recipe? Well, some of the like early signs, essentially if you look at your component and you're like, damn, this is doing too many things, that's probably a good sign that you can split it out in some way. And this approach of separation of concerns is a good way to start. If you look at it and you're like, oh, this component is responsible both for determining what something looks like as well as like what it does or like some kind of logic-based work, you probably want to split these into two components. Also, literally, you could just count the number of lines. If it has like thousands and thousands of lines inside of it, the component is too big and it needs to be split out into these kind of separate concerns, these separate components. So this pattern, the pattern of presentational and container components, is incredibly powerful. It's something that you can use in small apps and in massive apps. So it's a very, very scalable pattern, and it will immediately make your code base more manageable. So I really, really recommend that when you're working on your React apps, whether it's your next one or your current one, or if you're building a Vue app or whatever, just ask yourself, do I have good separation of concerns in my application? Have I separated my presentation layer from my logic layer? And I think start introducing this pattern into your app, and you'll find immediately your app is more pleasurable for you to work with and also for other developers to work with as well. OK, that's our second recipe. So that was the presentational container components. We talked about context API. And now I'm going to talk about our third one. Our third pattern that we're going to talk about, our third recipe, is called renderprops. And renderprops have been popularized by a lot of different developers. It's actually now part of the React documentation, so you'll see them in there as well. But I kind of first heard about it through a talk by Chef Michael Jackson. And he's an incredibly smart developer who has a lot of really awesome ideas. And he gave this talk about the value of renderprops. And to explain why you would use renderprops in the app, I'm going to kind of imagine a hypothetical scenario where we're building a puppy voting app. So we're going to build an app here that's essentially for voting on adorable puppies. So people see a photo of a puppy, and they can either say that it's adorable or incredibly adorable. That's basically the scale. So you're OK, cool, I'm going to start building this app. And the first thing I need to do is I need to build this puppy feed component, because I need to go get some puppies. It's not for feeding puppies. It's a feed of puppies. I need to go get them from the API. So you're cool, I'm going to build this puppy feed component. This whole example, by the way, was just an excuse to Google a bunch of images of cute animals. So the first thing that you're going to do is you're OK, I need to make an API request to /API/puppies. While we're waiting for this puppy data to come back, because there's a lot of adorable puppies, we'll surface a loading spinner. And then when the puppies come home, we're going to render them onto the screen. And if there's an error, we're unsuccessful in retrieving the puppies, which would be so sad, then we will render the error on the screen. So you build this, and you're dope, this looks incredible, super excited, it's testing well in the focus groups, and your manager, she comes to you and she says, this is great, can we do the same thing, but can we do it with kittens? Let's do a kitten feed as well. And so you're OK, cool, yeah, no problem. We'll follow a similar pattern here. We're going to do get/API/kittens. We're going to surface a loading spinner, and we're going to render some adorable kittens. If there is an error, we will render the error. And you kind of look at this and you go, interesting, very interesting. In fact, we're kind of doing the same thing twice, right? We're requesting this thing, servicing a loading spinner, rendering adorable creatures, and then if there's an error, rendering an error. And you go, the only real difference between these two is one renders puppies and the other one renders kittens. So you're OK, you put your dry hat on, your do not repeat yourself hat. You go, this is an abstraction opportunity. You get very excited and you say, let's create a pet feed. And the way that this pet feed is going to work is that you're going to pass it a pet as a prop. So you say pet feed, pet is equal to kittens, and that will get you kittens, and pet feed, pet is equal to puppies, and that will get you puppies. And you're dope, crushed it, nailed it. I've got this amazing abstraction here. It works for kittens and puppies. Later, if we wanted to have adorable turtles, we could probably use it for that too. There's a high level of potential with this. The next feature that your lead, she comes to you and she says, OK, this is awesome. We're doing really well. And now what we want to do is we want to have a user profile. And the user profile is, it's going to do a couple of things. It's going to get information about the user and surface that data into the screen. So you go, OK, cool. We're going to do get/API/profile. We're going to surface a loading spinner. You get the idea. It's very, very similar pattern. And then you go, oh, this is interesting. This is kind of like the pet feed. It actually does the exact same things as the pet feed, except it renders a user's profile. And then you think but the presentation of this is going to be different. We're not going to have a gallery of adorable pets. Maybe we're going to have some inputs here where you can type in, change the password or something like that. So you're how do I blend these things? How do I use my pet feed component here? Do Do I need to abstract that, or do I need to use like duplicate logic here in order to like make this work for the settings page? And while you're kind of like thinking about the best way to do this, your manager comes to you and is like, oh, I had this awesome idea. We want to do this. Depending on if it's loading puppies or if it's loading kittens, we want to actually have like a different spinner. So like if it's puppies, we want to have this like little dog prancing around. And if it's kittens, we want this like weird, mystic, upside down floating kitten. And so you think like, oh, well, actually they're like the same component, and like, I don't know, maybe I need to add like a conditional statement in the component. If pet is equal to puppy, then show that, or a kitten. And you sort of start realizing that your pet feed component is like on the cusp of becoming like spaghetti, essentially, at this point. It's an abstraction that's not working for you, and we can't use it for the user settings page either. So what happened? Like, we had such good intentions with our abstraction. So why did this happen? Well, the reason this happened is because tight coupling of our logic and presentation made our component less reusable and flexible. So because we connected our logic and our presentation to each other, we kind of got backed into a corner prematurely. So the solution to this is a pattern called renderprops. And renderprops, there's a lot of like confusing language around renderprops. This is actually the definition of a renderprop. A renderprop is a simple technique for sharing code between React components. Like really at a core fundamental level, that's what a renderprop is used for. It's just used for, you have some logic, you have a bunch of components that want to use that logic, so let's use this renderprop pattern, this renderprop recipe in order to share it. And it looks like this. The reason it's called a render prop, by the way, is because the name of the prop, typically, it doesn't have to be called this, but the name of the prop typically that you use in order to like take advantage of the render prop pattern is called render, which is kind of confusing because like that's also something that a component does. It like renders something, but I just want to point out that like if this prop was called pizza, then this would be called the pizza prop pattern. So this can kind of have whatever name that you want. So we need to think about how we can actually use this render prop in our app for our 3 different scenarios. We have this user settings page, this kittens feed, and this puppies feed. And the way that we can kind of use this is we need to realize that like there are things that these components have in common. They all request data from the API, they all need loading states, and they all have error states. But actually, the way that they render is quite different. Like they all render different things. The pet and kitten feed render things related to adorable kittens. The user component renders like settings. And they also render different loading spinners now, and potentially later could render different error states as well. So we have all these different presentational concerns that we're not going to know about yet. And again, as I said before, we want to try and defer the decision making around like what they look like till the latest time possible. So they have common logic and different presentation. And the way that we're going to resolve this issue is by renaming our pet feed component. We're going to call it a resource component instead. And this is a pattern that I used recently in an app at work. It was very, very, very successful approach. I'd say this component ended up being used like, I don't know, maybe 50 times in different places in the app. And like generally, like my new thinking about React and like building apps is like if you write a component that a bunch of other developers are using in a bunch of different places and it's working for all of their use cases and it doesn't have like a million props, that's something to be really excited about. That's something that you kind of want to shoot for, this awesome reusability. So how do we use this render prop pattern? It's actually very, very straightforward. This is the key though. When you're doing a render prop approach, what you need to do is in this resource component that we're creating, you'll see that in the render method, we call this.props.render. This.props.render. And again, remember we said that render could be called pizza, in which case this would be this.props.pizza. So don't get confused by the word render here. It's not doing anything magical. It's literally just a prop that is a function that you're calling. And what you pass into this function, you pass in the information from the state that you want to care about later. In our case, we want to care about our payload. Our payload is going to contain our puppies, it'll contain our kittens, it will contain our user settings. It's just going to contain an API payload of data. And we also want to know whether or not it's currently loading. So we want to know whether that data has arrived or it's on the way. If we were managing an error state here as well, which we probably should be, but just to keep the example small, we would also keep error information here. So if in our request, the request failed, we would store that information in the state here. The way that we use this is like very straightforward. So we have our two props here. We have a path prop, and you'll see that we're actually using that in our component did mount here. We call axios.get, and we pass this.props.path. That tells us what endpoint we want to hit. And so what we say is our resource component wants to access this path, and we're going to pass in our render prop here, and our render prop is going to have this data payload. And this data payload is literally just the state of the resource component. So inside of there, we're going to have access to data.loading and data.payload. And if we had an error, like we're handling errors here, we'd have access to data.error as well if we wanted to. So we have access to all of these props here. And what that means is that we can actually defer the decision making around how these components render to the specific place that we want them to render. So here, for example, this is the component that we're using on our puppy feed page. So we can actually handle all the presentation around showing a puppy in this view without needing to worry about making the request, knowing if duplicating the logic around like whether it's loading or not, any of those sorts of things. So all we're concerned with is the actual presentation here. And similarly, we can do the exact same thing with kittens, right? So we can see that all we need to change here is our path. We just change our path. And then we have access to the same properties. We have access to the payload, etc. But this time it will have our kittens inside of it. And even the user profile page, which is like completely different than the other ones, all that logic around requesting, loading, etc., that can all be handled by our resource component. And in here, we can have like a completely different style of presentation. We could have inputs, etc. We're able to handle all of those things in this view without needing to worry about duplicating the logic around how that information is requested. Also, incidentally, like the first pattern that we looked at, the context API, if you remember the way that the consumer worked is it had this value inside of it that uses a render prop as well. So this is a pattern that's really permeating its way through the React ecosystem. If you've ever used React Router has a render prop as well. All of these kind of recipes are all kind of intermingled with each other. So the idea here is we have the same logic, but we have different presentation. We were able to defer our presentation to a later time, which means when we get our fourth request for some other kind of API type thing we need to do that's not the same as user profiles or the same as pets or kittens, we'll still be able to use this resource component. So this component is incredibly flexible, and it's like looking towards the future for future uses. That is a massive win, especially when you start scaling a web application. Because when you, at TWG, we work in a very iterative way. We're discovering requirements on Monday and implementing them on Tuesday. So the more components you have that will help you build things you didn't know you had to build yet, the more valuable this will be in the long run. So render props, I think, are one of the most important patterns. Michael Jackson also in that same talk argues that actually they completely replace the need for higher order components, which is like a discussion for another time, but it's an interesting idea. They document incredibly well. They kind of use the declarative style that we're used to with React, so they kind of follow the React spirit of doing things. It makes it really easy when you look at a component at a glance to understand how it works. They separate presentation from logic, again, because they allow you to defer that presentation to a later time. And they also decrease code duplication because you only have to write our resource component once, and we can use it anywhere. They're super extendable, so other people can build on top of them really easily. They're incredibly reusable. Again, like proof is in the pudding. This resource component I built, I got used way more times than any component I've ever written. And they also abstract away logic, which is important for a language that doesn't have the notion of privacy. Because privacy doesn't really exist in in JavaScript. There needs to be ways that you can signal to another developer that's looking at your code, like, hey, here's the public-facing API, here's the things you should be concerned about, and then kind of abstract away the parts so it's like, you don't need to worry about this. This is kind of internal stuff that is managed by the component itself. When to use them, don't ever start with a render prop. This is like just a general philosophy I would really encourage. Don't prematurely abstract anything. Wait until you have to use it like 3 times before you abstract it. And the reason why I recommend that is because if you prematurely abstract anything, you will get the abstraction wrong. And the reason that you'll get the abstraction wrong is because you don't know the use case for it yet. So wait until you need to use it 3 times, and then hopefully, usually at that point, another developer on your team will be like, oh, I noticed that you wrote the same thing 3 times. This could probably be abstracted. And you will be like, you are correct. Share logic between components, but not UI. You kind of always want to do this, so it's a huge benefit. Other developers can, if you want other developers to reuse your code, which like these days is like the #1 thing that gets me excited about programming, is when I see other developers using components that I wrote. It makes me so happy. When you want to defer rendering UI to a later date, when you're dealing with common states or events, so for example, if you need to manage, I was working on a React Native project where we needed to know whether the keyboard was open or closed and stuff like that. It's really, really useful for those kinds of common events as well. Okay, so just some final thoughts. All of these patterns have to do with managing state, and I don't think that's a coincidence. Managing state, I have heard it said, I think it was Kyle Simpson who said this, that 90% of bugs come from improper state management or just like not having control of your state management. So just remember that if you truly understand the state in your app, that means that you will be able to have a fine-grained control over your app. Also, some of these patterns are actually more verbose than like a more abstracted pattern, and that's okay because the goal is never to actually write dry code. The goal is to write code that is easy for other people to understand. That's like the ultimate goal. Don't worry about it being too verbose. If it's so terse, it's like one line and nobody can read it, it's useless. It will never get used again. Cool. So this is our cookbook. This is your new cookbook that we kind of like worked on together here. We had our Can't See Dots homemade delicious context API, presentation container components a la Abramov, and Chef Jackson's renderprops, I forgot the accent grave, souffle. That's supposed to be souffle. Also, I think there's supposed to be an accent anyway. My French teacher would be so disappointed in me right now. So these are the 3 recipes that we learned about today. I just want to say really quickly that recipes are important for a couple reasons. They're battle tested, which means that chefs have gone into the lab with the sommeliers. They've done tastings, got feedback, read Yelp reviews, etc. They have a really good understanding of what is going to be useful in the most use cases. They're super easy to share because they're agnostic of code bases. They're just patterns you can use in any code base. They're really fun to use. They're kind of like a choose your own adventure that only has like a good path, which again, like none of you cook with a recipe, so maybe you don't want that, but but I find them really pleasurable because when I use them, I have confidence that they're actually going to work really well. And they're also familiar. So if I see another chef cooking a roux, I can say to her, hey, I know that recipe here. If you need to do something else, I can kind of take over for a little bit. We can trade off. So they give you that kind of familiarity among a team that's really, really useful. And the last thing I want to say is recipes are just a starting point. You don't need to exclusively follow recipes. They're just a place to start to teach you about some of the important patterns in your ecosystem. Once you feel like you have a good understanding of these approaches, that's when it's time, and they're like in your cookbook, that's when it's time to start writing your own recipes. So that's when you go out and you start building on these recipes and you start sharing those with the community and you start building your own cookbooks. Thank you.